like to start with a question. How many of you have used ActBlue to make a donation? 1, 2, 3, I don't see very well. How many of you tipped? Fewer. How many of you tipped $10 or more? I want to see the high. I can see here from here better. Who has the highest tip? Someone tipped. You tip here? Nobody tipped? How much? Okay, $5. You are the winner. I'm giving away I did this in our local Boston RV meeting, and someone had donated $100, tipped $100. So our app had its birthday after I sent the proposal. That's why I marked the 14 on top. And my name is Braulio. You can call me Brad if that's too difficult to pronounce. I'm with ActBlue 6 years. I didn't know that ActBlue was an early adopter until I made this presentation. I'm originally from Chile, in case you're wondering what country my accent is from. So in case you don't know ActBlue, the goal behind ActBlue is we all know we need money to win elections, but you shouldn't need the support of the wealthy. So ActBlue provides a platform that gives the power to the people. And you can do both things. You can run for office. Anyone can run for office using the platform and fundraise. But anyone can also fund their political candidate or campaign. It was founded in 2004 as a nonprofit. It's independent of political organizations like the DNC, the DCCC. And it's not only about politics, we also help nonprofits. And as of today, all the Democratic candidates for president are running using ActBlue. And in fact, there is a new rule that says to qualify for the debates, you can either have 1% on 3 national polls, or you can fundraise with 65,000 people. So how does the contribution form look like? There is an example there for a nonprofit, Save Animals Facing Extinction. Because I donated before, my name is on it, and also they have my card number, so it's as easy as clicking in one of the red buttons and a donation will be made. If you're a first-time visitor, you will need more information, the name, the address, credit card number, but it's the same concept. But ActBlue is not only about processing payments. We also help with compliance. We have a team of lawyers. We do the filing with the Federal Election Commission or state and local agencies, so the person fundraising doesn't have to do anything. We provide tools, A/B tests to maximize the conversion rates of the forms. We provide statistics and reports for the campaigns and integrations. If they want to know right away when a contribution is made, we'll send them a notification. Some numbers. In the last election cycle, we processed 41 million contributions, $1.6 billion. That's an 39 average each. And we helped 50,000 organizations. That's for the last 2 years. Lifetime volume now. This is since the beginning of ActBlue. And it's accumulated money in billions until today. So you can see it took 12 years to raise the first billion, then 2 years to raise the second, and 1 year to raise the third. I put also when I came to ActBlue in the graph, so you have, so you can see the correlation when things really picked up. Our application is called Indigo. It's a type of blue. All the blues look the same to me. That's why I had to put the hex code to explain what it is. And this is a piece of archaeology, the first commit in Rails. I want to prove that it's true. So at the bottom is the version of Rails, 0.10. from 2005. Now, you have to realize that 14 years is a lot of time. I bet some of you were programming in Java or .NET. Some of you were not programming. I see young people, maybe you were in high school. The author of the commit is Matt DeVergalis. He's one of the founders. The other founder is the other founder is Benjamin Run. So why did Matt do the first commit? Why do we do software? We do software because there is a business need. In our case, we are not a business, we are a nonprofit, so we call it an organization. But in most of your cases, it will be a business. But the business is not static. There will be changes, and we need to adapt to those changes. So the problem is that when you have long-running software, it will be more difficult to adapt. And there will be more lines of code, the team will be bigger. So the goal of this presentation is how we can do this more efficiently, how we can adapt to change at a low cost and quickly. At the same time, we have to keep reliability. We have to keep donations coming, and we have to provide security. We're saving credit card information, which is very sensitive, and also personal information. I have two examples there. No, one example of something that happened recently. We had to implement Apple Pay, and we were able to do it very quickly because we used the code we had for credit cards. Although this is different, still the code was good enough, and we understood how to make the change, and we did it very quickly. There is another thing we have to adapt. For example, we'll have the debates, we'll have the elections coming, the traffic is going to be a lot, and we have to be able to handle it. So what are the things that get in the way? What are these challenges for long-running applications? I put them in two groups. To the left, things getting old. On the right, things getting too large. And these are not specific to Rails. They would happen with any framework, and in fact, they happen on any software project. So the idea is that I'm going to share with you the lessons dealing with them, how we do it in Aglu. The first one is technical debt. Technical debt is when we choose an easy solution instead of a better approach that would take longer. So we go with the easy things quick. In a long-running project, if you're doing this a lot, you will have a lot of technical debt at the end. So it's a big problem. And the way we do it is we treat technical debt as a feature. Now, it doesn't mean, I know all of you are thinking, hey, this part of the code is ugly, we should fix it, and it bothers me every time I see it. That doesn't mean we have to do it. The only way you can address this is you have to make a case. You have to say why, what's the benefit. Normally, the benefit for technical debt will be that the code is more maintainable, can respond to change better, but you have to make an argument, and you will have to also specify how long it's going to take, and you will have to discuss this with the rest of the organization. There will be product people, there will be project managers, and everyone, you will have a long list of these, the technical debt plus all the features, and you will have to, they will be competing for their resources. We define priorities and have a short-term plan and a long-term plan. For technical debt, we address that when traffic is low. Normally, that's December after the election or after end of quarter. So I have two small stories here about this. One is, when I came to Aglu, I saw the code implementing PayPal. No, excuse me, Apple Pay, no PayPal. They look the same. No, it was PayPal. So the code wasn't very well structured, and I thought, yeah, sure, I can do something better. 6 years later, the code is the same. We haven't changed anything. But it's because there was no need. I mean, we rarely touch that code. So it's also very complex, and only 7% of the payments go through PayPal. So there is no real benefit there. The second story is with recurring contributions. The product people came and said, hey, when every time we receive a contribution, the donors should have a form giving them the option to make this every month. From that point, every month we'll repeat the same contribution. The developers thought, hey, who wants that? Nobody will use it. We did it anyway, and we were wrong. People really like it. Sometime later, people came back and say, now we want to do it weekly. We said, we were wrong with monthly, but we're certain this is not going to happen. And we were wrong again. So today, recurrent contribution is very important. We actually process 30,000 contributions every day only on recurring. And the feature has evolved. There have been changes to the way things should be. So every time we have to make a change, we are actually paying some of the technical debt. They ask something, and we realize, hey, we have things that we didn't do properly in the beginning that now we could fix them. So that's a very good tip. You tie technical debt to a feature. And in fact, if it was technical debt in the beginning, it's not that clear because we didn't know, we didn't really know. We didn't believe it either. But second point on H is obsolescence. What's the problem with obsolescence in software? Obsolescence is not about my code. It's about all versions of GEMS, for example, or the framework that are not maintained as the time passes. The problem is that vulnerabilities are found all the time. And you will be vulnerable if you don't patch, if you are not up to the latest version. It sounds obvious, but I know people running Rails 3.2, so it's a real problem. And how do we address it in a glue? Well, you need to have a good test anyway. I'm sure everyone here has a good test suite. But for upgrades, it's essential. Without the test suite, you won't be able to do anything. Don't skip the minor versions. The last line mentions 5.2.3. The minor is the second number. You should not go from 5.0 to 5.2. You should go from 5.0 to 5.1. Online, there is the Rails guides, which are excellent. If you haven't read them, definitely you should. But for upgrades, they are excellent. And the Rails guides on upgrade have specific instructions to go from version 5.0 to 5.1, and a different set of instructions to go from 5.1 to 5.2. So every time you upgrade, you should go to the guides, and they will give you a different set of instructions. They are very good. Additionally, you should read the release notes. It has extra information that might affect you. And also, once the test runs green, you should fix deprecation warnings. The warnings might not be on the standard output. You might have to go to the logs. And do not release the latest patch. The patch is the last number. In the slide there is 5.3. So you do not release 5.0 if that 5.3 exists. More lessons. These are not on the guides. Sometimes Rails or Ruby will provide something. In a new release, they will provide a new feature that you were taken from a gem. If this happens, you should drop the gem and start using the standard Ruby or Rails feature. You should try to release changes without having the upgrade. Before the upgrade itself, sometimes the upgrade, the release will say, we're deprecating this method. But the new method might already exist in the current version, so you should change it right away. Or they say, we are going to extract all this functionality in this gem, and the gem can be used right now. So you should do as much as possible before the upgrade. So the upgrade is as little as possible. Sometimes the gems are not maintained. You should fork them and fix them and release those changes to the open source community again. In our case, actually, Rails and Ruby haven't been that difficult. The gems dependencies have been a bigger headache. The only exception was Ruby 1.8.7 when we upgraded to 1.9. Ruby 1.9 introduced encodings. That's how I got the inspiration for the mug. There is a workshop on Thursday about upgrading Rails. If you haven't done an upgrade, I'd recommend going there. It's about 2 hours. The next topic is we will experience increased growth in code base. After 14 years, in our case, we have today 35,000 commits, 110 lines of source code, 120 top classes, I'm not counting subclasses, and 25 top modules. So has anyone here worked on a 10-year-old code base? Has anyone? Yeah. Do you think it's a mess? Yeah. So there will be, we have seen this. There will be parts of the code base where nobody wants to touch because they fear that will break the system. So I like to say that in software you learn to write before you learn to read. And that's why people tend to prefer working on applications from scratch, greenfield. And when you are working with legacy, the legacy has the connotation that the application is going to be replaced anyway. So you're doing isolated small changes only. So to me, coming to ActBlue, when I came, it was a 7-year-old app. So it was the first time I would see an application that was old, but it wasn't a mess. And in fact, I was supposed to understand everything. I was supposed to make changes anywhere. And that was a challenge because it was a lot of code and you're supposed to be reading and understanding everything. So the first thing to a good healthy code base is good Git commit messages. I like this source. There are many online. The URL is at the bottom, but if you Google Chris Beams commit message, it will be the top hit. There are 7 rules that he gives. I'm showing here just a summary. So there is one line, the subject, that explains what the change is in imperative mode. Then, optionally, you have a body separated by a new line that explains the how and the why. And in this case, I also have, I'm integrating with the tracking system, the bug tracking system that closes a ticket. So if you haven't worked for many years in a code base, you're not going to appreciate the value of this lesson. It happened to me when I was in ActBlue. After 2 years, I started reading my own commits. And I saw, oh, these messages are not very good. I should do something better, and I started doing this. So when you write a Git commit message, think of your future you. Your future you will be reading this. And it might be very clear to you now, but 1 year from now, it won't be clear. More about healthy code base. We all agree that a comment in the code is a lie waiting to happen, but having no comments is as bad. Having no comments at all is as bad. If there is a complex algorithm, you should write something explaining how it is, because reading the code will take time to understand what is happening. If there is something counterintuitive you are doing, you should also put the code there. The reader later might come and say, hey, this is not necessary, and they remove that. Documentation, also important. Personally, I like the data model documentation. I believe that if you understand the data model well, you can deduct the logic. So I love ER diagrams. A complete ER diagram is useless because it's too many things. But if I'm working on, let's say, payment processing, and I have an ER diagram of that piece with, let's say, 5 entities, it's very useful. When I came to ActBlue, there were no comments. There was no documentation. I think the guys were way smarter than me, and that's why they didn't need it. But it is better if you have it. It might be good for a team of 4, which what we had then, but today we have 20. And in fact, we have new developers coming all the time. So it really helps to have this. What happens when now the team is growing? The original team was just the 2 founders. We never had VC money to hire a lot of people. When I came in 2012, there were 22 people total in ArcBlue. Of them, 7 were technical, and of them, 4 were developers. So I was the 4th developer. Today, we have 120 people, 34 in the technical team, and of them, 20 are developers. So we all know that the number of communications will increase exponentially with the number of people. So when you have so many people, there will be a lot more things necessary to coordinate. You will have a lot to, we call it process there, or standards. You need a lot more to understand how people will be on the same page. So how do you help with this? You hire the best developers. They will be more expensive, but they will be more productive. The other approach is you treat developers as commodities and you keep putting them, but we think it's not a good idea because there is evidence that the best developers will be a factor in terms of productivity, more times more productive than the regular developers. There might be a discussion what that factor is. Some people say 10 times. Some people complain it's not 10, it's less. But it's clear that it's at least twice the good ones. So luckily for me, when I came in 2012, these guys had not figured this out. That's how it got in. Treat them well so they stick around. For example, send them to RailsConf with paid expenses. Good salary, good benefits. And it's not only about the money. I like to, from what I read, I make the other things in 3 words: autonomy, mastery, and purpose. If you give those to the developers, they will be happy and they will stick around. We also do code reviews. Every pull request has to be reviewed at least by 1 person. If the code review has more complexity, it has to be 2 people. But there is a discussion in the pull request. So some developers will say, why do you do it this way? Why do you do it that way? And in other cases, one developer will realize, hey, this is already implemented. There is a method in that class. Use that. And in other cases, there will be, you know what, we should close this, and you should start from scratch. It's better to do a new approach. We don't do pair programming in the strict sense of the term, but we do work in pairs. Someone more familiar with the code, with certain part of the code, will work with someone who is less familiar. We do that all the time. What else? Mentorships. Even a senior developer will have a mentor because it will be senior, but they will not be familiar. A new developer, they will not be familiar with the code, so it helps. I'm going to talk about complexity with an example from 2015. I already showed the contribution form from Save Animals Facing Extinctions in the beginning. After the form is displayed, there will be this step, the one you see there, asking for an optional tip. The donor can say continue, that's no tip, or they can choose a different percentage or amount. The problem we had at the time was if the user abandoned the browser, then there at that point, the contribution was not saved. So we were supposed to fix that. And don't try to read the flowchart. It's not there to read. It's only there to show you how complex the flow is for the contribution form. Those starts at the top left and ends at the bottom right. They are all the decisions that the contribution form has to make. Because when you make a donation, you might be giving away tickets for an event. So the contribution form has to ask for names. Or there might be a sticker or a T-shirt. The credit card might already be saved. You don't need to ask for that. Or what forms of payment you should process. Should you offer PayPal or not? So it was very complicated. On top of all of that, it is today highly optimized for speed. The most important speed in Indigo is how fast you show the contribution form. That is what most people see, and it's very, very important. So there is a lot of code to do it that way. So what do we do? We decided at that point that maybe we should separate. We should have a different application to do this. So we extracted all the code, and the new app was called Form App. And it was Rails, of course, but looking at that, we realized, hey, this is a lot of hand-coded JavaScript, and maybe there is a framework that fits well with this type of logic. We ended up writing Form App in React. So the lesson is take the best tool for the job. Sometimes that tool will not be Rails, it will be something else. But the beauty was now the rest of the app, the monolith, Indigo, was free. All the JavaScript there wasn't that complicated as Form App. So we could actually follow the opinion. Rails has its own opinion how Java should be handled, JavaScript. So we could follow that. And at the time, we had Ember and Backbone. We had all the frameworks in the app. So we were able to remove everything and do it the Rails way. Separate team also, separate app. It was a lot of improvement. This is the last topic. It's my favorite. If you're lucky, you will have this problem, which is a lot of too much traffic. I'm going to show two examples. This one is from September of 2009. Obama was talking about Obamacare, that's the Affordable Care Act, in a joint session of Congress.
The reforms I'm proposing would not apply to those who are here illegally. It's not true.
That was Republican Joe Wilson. He yelled, "You lie," in case you didn't hear. This is traffic in ActBlue. In contributions per hour, in September 9, there is the first spike. There was no Twitter, so I think that first spike wasn't very high because it was in C-SPAN and nobody watches C-SPAN. So the second spike was bigger the same day later on the news, and the big one was actually the next day on September 10, and there are big spikes later also. Most of the traffic went to the opponent, of course. So that's the first one. The second one is Bernie Sanders in 2016 was racing for the primaries with ActBlue. He won the state of New Hampshire in February, and he gave this victory speech.
I'm going to hold a fundraiser right here, right now, across America. My request is, please go to BernieSanders.com and contribute.
Look at the time, 9:37 p.m. Can you tell when 9:37 is? So the top graph is contributions per minute, and per minute. We were doing like 250, and we went to 2,600 per minute. That is about 40 per second. Now, a payment is a credit card being processed, and there are multiple calls to external services, so it's a very expensive action. The second one is requests per minute. We were doing 25,000, and we went up to 350,000. This is what we call feeling the burn. So this is lifetime. I'm showing contributions per month. The spikes are all in October of the election year, except in 2016. The higher point was in March instead of October. That was Sanders. Last election in October, we processed 4.5 million contributions in 1 month. No, those are per month. It's not per minute. I'm not showing per minute. I'm showing per month. The highest per minute was in the 2 videos I showed you. So every time there is high traffic or there is a big unexpected spike like in the 2 videos before, those are very valuable lessons. You have to look at those things and analyze everything, every little detail. There will be processes that responded well to the load and others that will not have responded very well. In our case, for example, we didn't lose contributions, but we had a backlog. We were not processing them as quickly as they would come. So you try to fix that. Another example was from the time we had a credit card vault that keeps tokens, and we have Indigo, and they have to talk to each other. And we realized that the connections were being closed on every request. So we fixed that. Do you remember this from 2008? So how do we do it? The main thing is architecture. How do we scale? How do we increase capacity? We increase capacity putting more servers. We increase the number of hosts, or we put more cores, more powerful computers. So if we have a process that is centralized, that something that is coordinating other things, and you have to go through that cannot scale because you cannot duplicate it. So all the code has to be able to run in parallel and concurrently. The problem is to write code that way is more difficult, and that's why we avoid it. But it's the only way. We also do load balancing. We do a synchronous job, and a synchronous job is when a request for a slow action like sending an email is received by the web server. The web server will not do the action because it's too slow. The web server will instead will put the request in a queue, and that will be served by a different host later. By the way, this is how we avoid losing contributions. We do this. We use caching a lot. We actually use servers called Fastly. It's a content delivery network, and it's not only caching, it's also distributed caching, which means that if someone makes a request in LA, there will be a Fastly server close to LA responding. But if we do the request in Boston, it will be a server from Fastly close to that location. Fastly calls them POPs. They are points of presence. I gave a presentation 2 years ago specifically about this because this is a big topic. In case you want to take a look, it's about backend performance. So last thing, if you pick the right framework and you pick the right language, it's going to be much easier to deal with long-running software. So we're very happy where Rails has been very good to us. We're very grateful to the people behind the 2 projects. And that's all I have. I hope you learned something today, and don't forget to read the Chris Beams Git commit message. Okay, we have 2 minutes for questions. Is there someone? Yes. Okay, so the question is why we decided with React instead of Angular. And I wish I could answer that, but I didn't make that decision. I'm more of a backend guy. I think I'm too old to be programming in JavaScript. Someone else more familiar with that part made that, but they evaluated everything. I think it depends on each case. The backend is Indigo. The question is, what is the backend for form app? So when there is a request, what's the endpoint? It's the monolith. Yep. So the contributions are not created in Formap. The contribution is created in the database and processed in Indigo. The question is what mechanisms we have in place to define how to stay on the current version of Rails. Upgrade as fast as possible. I think we are looking always at what things are going to be. When Rails publishes how long it's going to be maintained. So if there is a good margin to make sure that we're not going to be affected by that's enough for us. It depends a lot on the seasonality. For example, if we're close to the election, we cannot do it. So things like that will play. The question is, how do you scale?
Yeah, there is some dynamic scaling up.
Yeah, is how do we scale during the spike when we have, if we know that high traffic is coming, for example, we know for the debates there will be, we can put more servers beforehand. Yeah, so we increase the number of hosts. But there is also some tweaking. I mean, you have to, Sidekick will be, it is in the middle, this asynchronous job will be in the middle. You have to define those parameters properly, and Redis and the database, etc. So if you have a notification, you can do it. But if it happens suddenly, like with the July moment, there is no way. Because it will take minutes to put a new server online, so you don't have it. What happens in those cases is you will have a backlog, and if that is affecting things too much, you might decide to stop some services. You say, hey, let's say, I'm not going to take more requests for reports. I'm not going to take more requests for logins. Nobody can log in. Things like that. You have to, yeah, it depends on the case. We have 2 seconds, 1 second. That's it. On time. Thank you so much.